Okay.
Yeah.
Now, so I hope you know what is a set and properties of set. Like what is it mean by a empty set? You know?
Yeah, and that's it. There
Yeah.
are no items in that.
Yeah. Very good. Non-empty set means there are at least one element. Correct.
Yeah.
So using the idea of set, I'm going to define a new idea that is called A cross B, cross product of two sets. Okay.
Okay.
So you have two sets A, you have two sets A and B. So both are non-empty. Okay.
Okay.
So I am defining A cross B. So I will write first the definition of A cross B, then I will illustrate to using one example. So A cross B is equal to, A cross B is again a set. So we'll define like this one. It is a set of all ordered pairs. It's like a pair. The elements are like a ordered pairs. Ordered pair means order is very important. AB not equal to BA. Okay.
Okay.
So such that first element A belongs to capital A and second element B always belongs to capital B. So this is the definition of A cross B. So why I am defining this A cross B? We have to define relation first, then we have to define functions. Okay. So
Okay.
for that, the foundation is A cross B. Okay.
Yeah.
So I hope you understood. Just simple example. I'll take A equal to set 1, 2. Okay. And B equal to set AB. Now I am going to write A cross B. So A cross B is all ordered pairs. First element belongs to first set and second element belongs to second set. Correct?
Yeah.
So I will write 1A. It is possible. 1B. It is possible. 2A. It is possible. And 2B. It is possible. Is it possible to write B2?
No.
No, because B belongs to second set. So we can't write like this. So I will write this one. Finished? Everything finished. Every first element we consider 1A, 1B, 2A, 2B. So this is a very basic definition of A cross B. Okay. So actually what we are doing here is, suppose I am writing one diagram. See. Okay. So I am writing one. This is A. This is B. So what I am doing actually here is, I am writing 1, 2, A, B. Then I am mapping 1 to A. Correct?
Yeah.
That is the idea of 1A. Then I am mapping 1 to B. I am mapping 2 to A. I am mapping 2 to B. All the possible mapping I have done. Correct?
Yeah.
Yes. So that is the idea of A cross B. So from A cross B only we are going to define the relation. Okay. So suppose, yes. Suppose I take one set. Let us see. So A is this set and B is another set. Okay. So in A, I am writing the elements. First U. You are one member of set A. Okay.
Okay.
Suppose you have one brother and one sister. Okay. So brother and sister. And in B, your father and mother. Okay. Now the mapping I am considering, the relation I am considering is blood relation. Okay. If it is related, if it is your relative, then you can map. Okay. So how will you map? You to father, you will map. You to mother, you will map.
And then brother to father.
Yeah, brother also will map to father, mother, sister will map to father, sister will map to mother. Correct?
Yeah.
So what we are doing here, some relation we are defining from one set to another set.
Yeah.
Okay. Now, please listen. What is the definition of relation? So already you understand what is A cross B. Correct?
Yeah.
So any subset of any non-empty subset of any non-empty subset of A cross B is a relation. So in our previous case, already we define A cross B equal to set 1A, 1B, 2A, 2B, correct?
Yeah.
I am taking one subset. Just I'm taking one subset. 1A, 1B. Okay. So what is the meaning of this one? One is related to A, one is related to B. Finished. So this is an example for a relation. So for any two given set A and B, any subset of any non-empty subset of A cross B is a relation. So that is the definition of relation. No rules. No rules for a relation to be a function. There are some rules. That's why I'm telling. For become relation, no rules.
Okay.
So I hope you know how many subset a set with the n elements or 2 elements. Suppose one set has 2 elements. Okay.
2 elements, so 4.
Yeah, 2 square. So generally, if the cardinality is n, the number of subset is
2n.
number of
2 to
subset
the
is
power of n.
2 raised to n. Correct? Now tell me how many relations possible from A to B here
Okay,
in this
well,
example.
we have 4 elements. So
Yeah.
16.
How many subset this set have?
16.
Yeah, 2 raised to 4. Correct. 16.
Yeah.
So 16 relations are possible from given example A cross B.
Yeah.
Is it clear?
Yeah.
Yeah. Now I am going to define what is a function. Okay. Before going to some remarks, examples, I have to teach you what is the purpose of this kind of why we are defining A cross B, why we are defining relation. The basic idea is we want to define function.
Okay.
So for defining function only, we define relation. For defining relation only, we define A cross B. Okay.
Yeah.
Now, so you know what is a relation? It is any subset of A cross B is a relation. Now, I am putting one rule in a relation. So, a relation is said to be function for every element of first set there exists a unique element in second set. So then only a relation become function. What is the meaning of that? First idea is, first set A. Okay.
Yeah.
So we will define in A this example only. 1, 2, B equal to AB. Okay. So not all relations are functions. Not all relations are function. A relation to be a function for every element of A. So one have an image and 2 also have an image. So suppose you take this one. So this is not a function. Why? Can you say why it is not a function?
Because it's only using the first element in the first.
Yeah. The second element does not involved in the relation, correct?
Yeah.
So that is necessary. For every element, there are at least one single image is there. We'll call it as image. Okay. Now, one more idea is there. Not only for this point and this point, it should be unique also. That unique case also this failed because one has 2 images, correct?
Yeah.
That is not possible. Every element has only unique image. Then only it become a function, correct? So suppose if you take 1A, 2B, This is okay. Every element have image, correct?
Yeah.
Every element have unique image.
Yeah.
Okay. Now this also possible. If you take 1A, 2A, see every element of image, every element has unique image. That is A. That is not a problem. See, please remember, in second element, image same is not a problem. For a single element in first set, it cannot be a different images. That is the idea.
Yeah.
You understand?
Yeah.
Yeah. So that is the definition of a function. So we defined the Cartesian product A cross B. We call Cartesian product. Then we define what is mean by relation. Relation is any subset of any non-empty subset of A cross B. Then a relation is said to be a function. For every element of first set, there exists a unique element in second set. Okay. So let us do some. We'll try some problems.
Yeah.
So then we'll understand more. Okay. So yeah, my first question is. First of all, I will ask you one question. I already told you in the A cross B there are ordered pairs.
Yeah.
So A cross B is set of all A B such that A belongs to A and B belongs to B. So AB not equal to BA generally, correct?
Yeah.
When two ordered pairs are equal, when will it will equal? When will you say two ordered pairs are equal?
If they're equal, the sets
Yeah,
have the
this
same elements in them.
means the first element in this one is equal to first element in this one. Second element in this one, which is equal to second element in this. Then only we can say that's are equal. Correct?
Yeah. Yeah.
So there is one question in your textbook. They are given that x plus 1, y minus 2 equal to 3, 1. Ordered pairs are equal, they are given. Find x and y. I think it is very easy. Correct?
Okay. Because
Well,
they're ordered pairs, we know x plus 1 is equal to.
yeah. X plus 1 is equal to
X plus 1 is equal to 1.
No. X plus 1 is first one. Here first one is which one?
Oh, yeah, right. Yeah. X plus 1 is equal to 3 and
3
y
and
minus
y
2 is equal to 1.
1. So x equal to 2 and y equal to 3.
1. Sorry, 3.
Correct?
Yeah.
Correct only, correct?
Yeah.
Now my next question is P a set is given A, B, C. Okay?
Okay.
And Q is a set given R. One single element. Can you tell me what is P cross Q?
P cross Q will firstly A comma R,
Yeah.
but then Q only has one element. So
Yes, correct. Then
B comma R and C comma R.
very good, very good. Now let me ask Q cross P. Is it same?
No, it's not. So we
Yeah.
have R comma A, R comma B, and R comma C.
Very good, very good. So in general, what we can say, P cross Q not equal to Q cross P. Q cross P. Okay?
Yeah.
Yes. Okay. So let me ask you one more question. So I hope you know what is the intersection between two sets.
Yeah, the common elements.
Yeah. What about union? A union B.
So the elements in
Yeah.
A plus the elements in B.
Correct. So let me a simple question. I think you can see answer very fastly. So B is equal to 3, 4, and C is equal to 4, 5, 6. Okay, fine.
Yeah.
Now my question is, what is A cross B intersection C?
Okay. B intersection
So for
C.
that, yeah. So for that, first you write what is B intersection C.
B intersection C is just 4.
Yeah,
B.
very good. So what is A cross B intersection C?
A cross B. So 1 comma 4, 2 comma 4, and 3 comma 4.
Very good. So I hope you understand what is meant by
Yeah.
this all things. Okay. See, I will tell you one interesting thing, geometrical thing, because we are taking here product, correct, Cartesian product, correct.
Yeah.
So let me ask you, if you take first set as R, you know, I think set of all real numbers.
Real numbers.
Okay, you take B as again R, same R. Okay,
Yeah.
so geometrically, what is R? Can you say geometrically what is R? Real numbers.
Geometrically.
Yeah. How will you represent? How will you represent real numbers geometrically?
I don't know.
In a straight line, you will draw one straight line. I think
And
you
then
study
2
in school. Yeah.
arrows. Yeah.
Yeah. Then zero. So it is geometrically a line, straight
Yeah.
line.
Okay.
Correct. So
Yeah.
what happen if you take cross product with the R and R? So I am asking about R cross R.
So the set will have an infinite number of elements.
Elements, correct. It is set of all A, B such that A belongs to R, B belongs to R, correct?
Yeah.
So what is, you can tell what is the geometrical idea of this one? R you told it is line. What is R cross R? Yeah,
Uh,
for R cross R, this one. See, this is the geometrical idea of R cross R.
okay.
So this is x-axis, this is y-axis. Every point in this one we represent as ordered pairs, correct?
Yeah.
Yeah. So if you take R with the Cartesian product R, you will get the plane, whole plane.
Okay.
Okay. So that is one interesting idea. So if you take real numbers cross real numbers, you will get the whole plane.
Yeah.
Now you already define A cross B. How will you define A cross B cross C? Is it possible?
Um,
Like only
yes,
we
it
will
is possible. Yeah.
yeah, we can't say it is ordered pair. We will say it is ordered triplet.